how they compare to, or how they're different than what you did in lab last week, which was what? What types of compounds did you look at in lab last week? Do you remember? Ionic compounds. Okay, so let's use that as a reference. So in ionic, so versus ionic compounds, we saw in those types of compounds, in order for them to be ionic, we had to have the presence of ions, right? And what is an ion? Or what was an ion? Something that had a charge on it, right? Either positive or negative. And those ions were produced because your substances, your elements, were either losing or gaining electrons. And when they lost electrons, they formed these positive ions. When they gained electrons, they formed these negative ions. And then those opposing charges attracted each other. And that's what we ended up with our ionic compounds. And we went through the naming and everything else associated with those. So the loss or the gain of electrons, right, is one way by which these elements can become more stable. Right, we said that that was the driving force for your elements either losing or gaining electrons. The third way by which your elements can become more stable is by sharing. Electrons. And that's what we're going to focus on today, and it's what you looked at in lab on Monday and what you're going to look at in lab today. So when we start sharing electrons, we're going to encounter a different type of compound known as a molecular compound, which are also called covalent compounds. And these types of compounds will form when elements, and specifically our nonmetals, share. Electrons, right? So these are two important differences between our covalent compounds and our ionic ones, the types of elements involved. In your covalent or your molecular compounds, we're only going to see nonmetals. And in your covalent or molecular compounds, your electrons are being shared. Right? And in our ionic compounds we saw last week in lab, usually there was a metal in there. And there wasn't any sharing electrons, there was a transfer of electrons from the metal that lost it to the non-metal that gained it. Right? So those are two very, very important differences between ionic compounds and covalent compounds or molecular compounds. The other main difference is how we actually name our molecular or covalent compounds. And when it comes to the naming or the nomenclature, that's a fancy word for names and formulas, we encounter the other big difference between ionic and covalent, which is in our covalent compounds, we're going to be using prefixes. That tell us how many of each element we have in a molecule. Do you remember using prefixes last week for your naming of ionic compounds? We did not use any prefixes. There were a couple people that wanted to use prefixes, and I said, no, don't use them. Because we don't use prefixes in naming our ionic compounds, but we always use them for our covalent ones. So these prefixes are going to tell us how many of each element there is in a molecule, and these are the prefixes that you need to know. All right, so 1 through 10. So the prefix for a couple of these here, you'll see you may have seen before or maybe familiar with them. Others are a little trickier to know, so we'll go through all of them. So 1 is mono. Right, you may have heard that one before. Similarly, di is for 2. Tri, like a tricycle, for 3. Right, so the first 3 prefixes may be prefixes you may have seen before. 4, most likely not. So the prefix for 4 is tetra. That's one that tends to be confusing because it's not something that you typically associate or you've seen previously. 5, penta, like pentagon, 5-sided pentagon. Similarly, 6, hexa, like hexagon. 6 has an X in it, hexa has an X in it. 7 is the other tricky one. 7 is hepta. And I'll tell you right now, students often get 7 and 4 confused for whatever reason. So pay extra attention to those, right? 7 is hepta, and then 8, like octopus, octa. 9, nona. 9 has 2 N's in it, like nona does. And then deca for 10, like decade, 10 years. Right? So there are little things in the prefixes that you can use to help you remember what they are. Some are going to stick in your head really quickly. Others you have to spend a little bit more time on. All right, but you need to know all of those 10. We're going to use those to tell us how many of each element we have in a particular molecule. All right, so let's take a look at a couple examples. Let's say that we have something like CO2. So when we name our covalent or our molecular compounds, it's going to look similar like the ionic compounds, meaning there's going to be a first name and a last name. All right, so the first element as written, we're going to write it. So C, as you may know by now, is carbon. And we have 1 carbon in there. Right, so you may be tempted, well, should it be monocarbon to tell us that we have 1 carbon? Well, that's the only time you don't need a prefix, is if you have 1 of the first element. Every other instance, you're going to need a prefix. So only time a prefix is not needed if there is 1 of the first element. So we don't need a prefix for carbon in this case. It's just the first one, and there's only 1. What's oxygen as a last name? Oxide. How many oxygens do we have?
2.
Prefix for 2 is di. So carbon dioxide would be the name for that. Carbon can also combine with oxygen in a different ratio. CO, big C, big O. What would be the first name for that one? So carbon, we have 1 of the first element, so we don't need mono. What's oxygen as a last name? Well, oxygen as a last name is oxide. And now we have 1 of the second element always gets a prefix. We have 1 oxygen here, so it would be mono. Right, so carbon monoxide. When you have those 2 vowels that are right next to each other, you typically drop the first one. Right, so we drop one of the O's and we end up with carbon monoxide as the name for that. Right, so carbon monoxide, CO, carbon dioxide, CO2. What about if we had something like S2Cl7? So what does S stand for? So it'll take you some time to get used to the names and symbols, but S is sulfur. It's not sodium. Sodium's Na. So S is sulfur as a first name. How many sulfurs do we have? What's the prefix for 2? Di. So disulfur would be the first name. And then Cl is, as the last name, is chloride. And we have 7. Do you remember what the prefix for 7 was? Hepta. I know we just did it 2 minutes ago, so it may not be in your brain. Disulfur heptachloride. Okay, it's that simple for the nomenclature. It's way easier than your ionic compounds, as long as you know the prefixes. Right? That's the only thing really that you have to sort of memorize here are those prefixes for the numbers. Right? And some of them, like I said, you may already know. Others you have to spend a little bit more time on. So if I give you the formula, you should be able to name it. And then similarly, if I give you the name, right, you should be able to give me the formula. All right, so let's take a look at this one. NBr3. First name. N is nitrogen. I have 1 nitrogen. Do I need the mono for the first one? No, leave it out. Br is, as a last name, bromide. Right, remember it has to have that IDE ending. You have 3 of them. What's the prefix for 3? Tri. So nitrogen tribromide. All right, let's go in the other direction. If I give you the formula and you have to name it. So let's do CCl4. Or that's the same direction, sorry. So CCl4, let's do that one. First name. C is carbon. Last name for 4 is tetrachloride, exactly. All right, and let's do one in the other direction, all right? So all of the examples we looked at so far, you have the formula and you have to name it, so you need to know the prefixes. If I give you the name, you should be able to do the opposite, right? Come up with the formula. And that actually is the easier of the two, as long as you know the prefixes. So, diphosphorus pentoxide. Diphosphorus. Di meaning 2 phosphoruses, or phosphori. What's the symbol for phosphorus? P. So I have 2 P's and then pentoxide. Pent, 5, oxide, oxygen. 5 oxygens. What about this one? Dihydrogen monoxide. What would be the formula for that one? Dihydrogen meaning 2 H's. Monoxide, 1 O. H2O, right? That's the chemical name for water, if you wanted to name it according to the rules. But several of the covalent compounds, they usually have common names associated with them, right? And water is one example. It rolls off the tongue a lot easier than dihydrogen monoxide. But if you had to name it according to the rules, this is what it would be. All right? So, when it comes to the naming of your compounds, as we've seen here now, there's a big difference between what you learned last week in your ionic nomenclature or your ionic naming versus now with your covalent ones. So the first thing you have to do if you're given a formula for something is you have to know whether it is ionic or whether it is covalent, because the rules are very different for naming them. So how can you tell something ionic from something covalent? Well, you look to see whether you have only non-metals in there, or whether you have metals in it. So once you see a metal in a formula, right away think ionic. And you use one set of rules. If you notice any polyatomic ions in there, it has to be ionic. If you only see non-metals in it, it's going to be covalent or a molecular compound. And you use the prefixes to name it. All right, so you want to make sure that you use the appropriate or the applicable rules when it comes to the naming, and it all starts with identifying something as being ionic versus being covalent. All right, questions so far on the naming of covalent compounds? Okay, so the key thing here is to know those prefixes, right? And prefixes by default go at the front of something. The only time you don't need a prefix is if you only have one of the first element. Then we can leave the prefix out for that first element. All right, so